In our warm-up today, every measure of central tendency was the same. Every measure of central tendency of Equatortown and Texasville were all 79. So what do we conclude from that? That both cities have the same, or the temperature over the course of a year the same in each of those cities. Central tendency says, yeah. Are they? No. Not even close. They are not the same. They're very different from each other. We can look at the raw data and it says that, yeah, it's got to be different. It's not the same. It's not even close. But unfortunately, central tendency isn't good enough to tell us anything about that. If you didn't have the actual data, you'd only have these measures, and you say, yeah, it's got to be the same, because all the mean, median, mode are all the same. But they're not. Central tendency was not good enough. They're not. They're not the same, but central tendency is not good enough. To tell the difference. They're not all identical. But if we just looked at central tendency, we wouldn't be able to tell the difference, which is not really good. Standard deviation is a measure, or the measure, of how far on average each piece of data is from the mean. In particular, standard deviation symbol is the Greek letter sigma. Sigma is like an O with like a curly Q on top of it. Is the symbol for sigma. Okay? Sigma represents standard deviation. And the formula for standard deviation goes something like this. Sigma is equal to, there'll be a fraction. And it's going to get a little bit on the messy side, so please bear with me. We'll explain all the different parts. First thing we're going to do is take the first piece of data. I'm going to call that x1, x with a little 1 underneath it, to say that's the first number in my set of numbers. And I'm going to subtract that from the average, or from the mean. The symbol for the mean in statistical world is x with a line over top. It's called x bar. And if this is going too quick, or this is just too much for everyone, just if I agree, you just copy it down. We'll go back over when we're finished with it. Okay, so don't worry if you're like getting floating in all this symbols. We'll put those in parentheses, and we're going to square that once we've subtracted them. Then we're going to add to that. In parentheses, we subtracted the first piece of data from the mean. Now we'll subtract the second piece of data from the mean. So what do you think I'm going to use as symbol for the second piece of data? X with a 2. So I'll do x2 minus the mean, which is x bar, and square. And then if I have 3 pieces of data, what's the next thing I'm going to do? x3 minus the mean, and so on. I'm going to represent that pattern with this what's called an ellipses. It's 3 dots. That means continue the pattern. Keep going. Keep going. Keep going. We said the measure is on an average. How far you are away? So if it's on average, then what do we have to divide our fraction by if we're finding an average? Joe? The total number, how many there are. I'm going to represent that with the letter n. N is the number of pieces of data. Okay. And last but not least, it's a distance. How far away a distance. If you recall, you may not remember, that is the distance formula between 2 points in a plane. You may remember it from way back in Algebra 1. The distance formula is a square root. So ours will have a square root. We'll square root everything. Okay. First step, if we want to use that, in order to find and use that formula, we need to find the mean. If we want to calculate the standard deviation of a set of numbers, first figure out what the mean is. And call that mean the mean. Another symbol for mean is x bar. Find the mean, we'll call it x bar. Step 2, once you know the mean, inside those parentheses we want to subtract the mean from each piece of data. So subtract the mean from each piece of data. So if you had 5 numbers, you'll subtract the mean from each of those 5 numbers and you get 5 new ones in step 2. Once you've subtracted the mean, what's the next thing we do? Square it. So now we'll square each new number. Yes, ma'am. The mean from each piece of data. Yes. So that's the first one, yeah, right? Mean from each piece of data. Okay. Joel. Why are we... Step 4 is now add together everything from step 3. Add everything together. Once you've added everything together in the numerator, what's the next thing we want to do? Divide by how many?
The number, divide by n.
Divide by n, which is the number of pieces of data. And once you've divided by n, what's our final step? Square root. Find the square root. First step, what do we got to do to find the standard deviation of those 5 pieces of data? Okay, so what's the mean? The mean is 17.2. What do we do next? Subtract from each piece of data. So the next step, we'll take 12 minus 17.2, and 17 minus 17.2, and 18 minus 17.2, and 19 minus 17.2, and 20 minus 17.2. And you get 5 new numbers. Okay? Should get and if I did my mental math correctly, we should get negative 5.2, negative 0.2, negative 8.2, negative 8.2, times fed. 0.8, 1.8, and 2.8. Is that correct? As we go? What's step 3? Square each of them. Okay. If you multiply a positive number to a positive number, what kind of number do we get? Okay. If we multiply a negative number to a negative number, what kind of number do we get? Okay, so then what type of number should every one of these squares be? Positive. Positive. Make sure you get positive numbers when you're squaring them. Therefore, completing steps 4, 5, and 6, the standard deviation is exactly 2.79.